welcome to Algebra 2 class today, folks. Today we're going to be doing section 7.5, which has to do with properties of logarithms. Our first one we're going to talk about is called the product property. So if we take a logarithm of base b of two things that are multiplied together, that means we can expand them by adding them. So that means I can take log base b of m and add it to log base b of n. So our first property is if we multiply, then we can add the two logarithms. So logarithms, remember, have a lot to do with exponents. So same thing when we multiply two things with the same base together, we add the exponents. So for logarithms, if they have the same base and they're multiplied, that means we add the logarithms. Okay? So quotient property. What's a quotient? What does quotient mean? The result of what? Division. So if I take two things with the same base and take the log of them and they're divided, well, what did we do with the exponents when we divided two things with the same base? If I have two things with the same base and I divide them, what do I do with the exponents?
Add.
Not add, subtract. So same thing with logarithms. They have the same base and they're divided. I subtract top minus bottom. So that's the quotient property. And then we have the power property. Take the log of base b of m to the n power. All you do is rewrite it with the exponent in the front. So that's going to be n times the log of base b of m. So these will help us expand logarithms. The first thing we're going to do with this is they are going to give us a decimal to tell us what they represent, and we're going to expand it using these properties. So they're going to tell us, for example, on this one, to use log of base 4 of 3 is approximately 0.792, and log of base 4 of 7 is approximately 1.404. And y'all bear with me a second. I'm going to get my calculator out. I'm going to find it. Get it turned on and going. Okay. So example 1 today says the log of base 4 of 3/7. Well, that's the quotient property, is it not? 3/7 is a fraction, which means those two things are divided. So that means I can subtract log of base 4 of 3 minus log of base 4 of 7. Y'all see that? From that property right here. Quotient, if I have a fraction, I do the log of the base of the numerator subtracted from the log of the base of the denominator. So I split 3/7 in like this. And we said they gave us the decimals to use, right? So for this problem, I'm going to be saying 0.792 minus 1.404. And then I just type that into my calculator. 0.792 minus 1.404. And I hit enter. And what are we getting? Yes. So, negative 0.612. Y'all see how I did that? I used the properties of logarithms to expand the logarithm, and then I just plugged in the two decimals that they told me to use. Does that make sense? Okay. All right, the next one might be a little bit more confusing. This one wants us to simplify the log base 4 of 21. But they didn't give me log base 4 of 21. They gave me log base 4 of a 3 and a log base 4 of a 7. So how can I make 21 out of 7 and 3?
7 times 3.
Yeah, so I'll just change it to log base 4 of 7 times 3. And isn't that the product property? So what did it say to do if I multiply two of them? Split them up how? Where I can add them. So that's going to be log base 4 of 7 plus log base 4 of 3. What's log base 4 of 7? What decimal am I using for that? I told me to use 1.404. And I add that to log base 4 of 3, which is 0.792. So I put that in my calculator. That's what it told me to use. Sorry, I can't have my calculator and my screen at the same time. So I'm using these two. When I say log base 4 of 3, I use that. When I say log base 4 of 7, I use that. So I'm adding those two together. What are y'all getting? 2. Okay, sorry, I lost my place. 2.196. Any questions about that? Let's do another one. Log base 4 of 49. Well, how am I going to get a 49 when I just have a 3 and a 7? Square the 7, right? Does that make sense? Because all I have to work with, y'all, is the 7 and the 3, right? So I have to make this number come out to be something with a 7 or a 3, or both, right? So 49 is the same thing as 7 squared, is it not? Now what do I do with the exponent? That power property tells us to do what? Bring the exponent to the front, right? So that's going to be 2 times the log base 4 of 7. And what is the log base 4 of 7 equal?
1.4.
So in our calculator, we're going to hit 2 times 1.404.
2.808.
I believe you. 2.808. Any questions about those? It's just all about using those properties. Okay, so here's another set of them. They're going to give us some more decimals. This time they want us to use log base 6 of 5 is approximately 0.898. It will be. It's approximately 1.161. Okay, so now we got log base 6 of 5 and a log base 6 of 8 that we're going to make sure all our problems convert to. So example 4, let me highlight those. Example 4, they want us to do log base 6 of 5/8. So how do we expand it if they give us division?
Subtraction.
We subtract. So log base 6 of 5, 6 of 8. And we just insert those decimals. Log base 6 of 5 is 0.898 minus log base 6 of 8 is 1.161. And what do you get when you subtract those two? It's going to be a negative.
-1.264.
That's it. Any questions about that one? So you expand it and then change your decimals. That's all you do. Put in your decimals. So number 5, log base 6 of 40. Now how are we going to do that one? Right, we have to use 8 and 5, or some combination of an 8 or a 5, because those are the only two I know. So 40 is 8 times 5, so it's log base 6 of 8 times 5. So how do I do that?
Add 'em.
Split them up and I add them. So log base 6 of 8 plus log base 6 of 5, which means I say 1.161 plus 0.898. So y'all can tell me what I get there.
2.
2.059.
0.59.
Yes. Questions there?
Nothing more.
Oh, I skipped number 5 when I was doing my notes. I'm like, these numbers don't match up. So if my numbers get off, y'all just tell me. What about log base 6 of 64? How am I going to use that where I can use these decimals? What can I change that to?
8. 8 squared is 64.
8 squared is 64. Good. So I can say log base 6 of 8 squared. And how do I expand my logarithm when I have a square or an exponent on my number? It's off of my screen by now. You bring the exponent where? To the front. So it's 2 times log base 6 of 8. And what is log base 6 of 8? What decimal am I using?
Could be 2.2 or 2.3.
Oops. 2 times 1.161.
2.32.
2.322. So any questions on about what to do when they give you one of them with the decimal? Okay. Well, that is the front side of my notes. So there you go. So the next thing we're going to do is expand a logarithmic expression. And we're going to use those 3 properties we just talked about. Not equation, it's an expression. So when we multiply them, we add them. When we divide them, we subtract them. And if we have an exponent, we move it to the front. Right? Okay. So we're not going to actually solve these or work them out because we won't know what decimals they round to. So we're just going to expand it. We're going to have the word log written a lot of times. Okay? So what number example are we on? 7? Okay. Log base 6 of 5x to the 3rd power divided by y. So if we have a fraction, they're doing what with the numerator and denominator? I just said they're dividing, so we subtract them, right? So the first thing I would do is I would split those up, numerator, and then subtract the denominator. Are y'all with me there? Dividing means subtract. Now this one's got a few things going on right here. Okay? What does this 5x to the 3rd mean when it's all squished together? Those two things are doing. They're multiplied. So how do I expand multiplication with logarithms? Add them. So I'm going to say that is log base 6 of 5 plus log base 6 of x to the third. Then I'm going to subtract that y. And there's one more thing I can simplify. Do y'all know what it is?
Power.
The exponent. So what do I do with an exponent?
You move it to the front.
I stick it in front of it. So this one is log base 6 of 5
Plus 3 times log 6x
minus.
log 6y.
Very good. So the first thing I did was subtract it because they were divided because it was a fraction. Then I split up this into these two parts, and then I fixed this to the front. And this is my final answer. You just breaking it down to where you have no exponents left and you don't have anything stacked on top of each other or anything squished together. Let's do another one.
So what does log to the 6 mean?
Log base 6.
Yeah, what does that mean?
You're saying with a base of 6, what exponent equals 5? 6 to what power equals 5? Of course, it's going to be a decimal because there's no whole number that it works for. So that's what you're doing. Remember, logarithms are the inverse operations of exponents. All right, let's do another one. Log base 7 of 3x to the second power over 5y to the third power. So it's slightly going to be bigger than the last one.
Log base 7.
So what are we going to do to them first?
Subtraction.
Yeah, when I have a fraction, it's subtraction. So log base 7 of 3x squared minus.
Log of 7 5y to the third.
Okay, then what do I do?
You know, break it down even more. So log of 7.
3. Yeah, they're multiplied right there, so I add them.
Plus log 7
X squared. And then same thing right there.
So minus log 7 to the fifth of 5 plus
Log 7th of y to the third. And what's the last thing I can do?
exponent.
The exponent. So this one and this one, and they just go in front of that log.
So log of 7 plus 3.
Log base 7 of 3 plus,
Log
wait, what goes in front?
2
2 log base 7 of x minus
log.
log base 7.
Mom, this is tongue twisting.
It is. Plus, what's the last one going to be?
3 times log of 7y.
Base 7 of y. And that is your final answer for that one. Well-
it's too much. No, it's not.
Y'all, logarithm is just exponents, so it's just exponent rules.
All you have to do is break it down.
It reminds me, you're just spreading. Yeah, you're writing the word log 50,000 times. No big deal. All right, y'all try this. I'm gonna give you a really easy one, and it's so simple it might be difficult because we've done harder ones than this. Expand this. If I could spell the word expand, it would be good today. Thank you. Okay, if it does not give you a base for your logarithm, what is the base automatically?
0.
No,
1.
no.
E.
10. No, that's alien. That's natural log. So if they don't give you a base, the base is 10 automatically. So this one automatically has the base of 10. So you don't have to write the 10 when it's base 10. You just understand it. And that's the one your calculator will do. Expand that.
Log of 3rd plus.
Not my style. I know you guys split up the 3's and X. So they split them up first because they're multiplied so you can add. So they log 3 plus log X to the 4th and bring the 4 in front of the log X.
Oh my God. Why this log? Like, why? And we need to hear me do the test and stuff on this so we can get done with
After Wednesday.
this.
Then it's on your state test, so have fun with that. Why do you think I'd cover it? Because it's on your state test. There's legislators that think you need this stuff. You will see it again in college algebra if you ever take algebra in college. All right, so first of all, this 3x to the 4th, what's going on with them mathematically? They're multiplied, so what do we do to split it up?
Log to the third, log to the 10th. So do you want us to write 10 when anything going?
No, you don't have to write 10s off. That's just log 3 plus log x to the 4th. And what do you do with the exponent?
Put it in the front.
Put it in the front of that one.
Plus log 4 times log x.
Plus 4 log x. Raise your hand if yours looks like mine. Not, mine's wrong. If yours looks like mine, it's wrong. It's supposed to be a plus in the middle. So any questions about that? So you will have some of those on your homework. Well, the opposite of expanding means make bigger, right? So condensing. Okay? So now we're going to condense it, which means make it smaller. Condense a logarithm. So first we expanded. Now we're going to condense them. This is number 9. Log. So if it doesn't have a base given, what is the base? 10.
So we're contracting it?
Yeah, we're making this written as one single log instead of a bunch of different logs. So this makes more sense, doesn't it?
Yeah.
We're making it log. So it's going to be log base 10 of something.
Log the 10th, base 10
Of
9.
Okay. This plus means I'm going to do what? Multiply. The minus means I'm going to divide. Or the subtraction means I'm going to divide. And this 3 is going to be 2 to the 3rd power, right? So it's going to be 9 times 2 to the 3rd power divided by what?
3.
That's supposed to be 3 like this, not like 3 isn't a base. I'm sorry. Divided by 3. Y is what? Yeah, M for multiply. So if we say a plus, they're multiplied. A number in front means it's the exponent. Subtracting, we're divide. So we're going to simplify this. What is 2 to the 3rd power?
6.
No. What is 2 to the 3rd power? No, it's not. It's 8. So this is 9 times 8 divided by 3. What is 9 times 8? Y'all are all killing me today. I'm asking you 2nd grade questions. What's 9 times 8?
72.
Divided by 3 is what? What's 72? 24. So it's log base 10 of 24 is my simplified logarithm. Look how much that's simplified.
It's Monday and we've been adding.
I'm rolling my eyes.
Yeah, we didn't sleep this morning.
Whatever.
I ain't go to sleep about.
Okay. That ain't my fault. Personal problem. All right. We haven't done a natural log today, so let's do those. LNs are just base E logarithms. 3 ln 3 minus ln 12. Let me get some more space going on right here. All right. So if we see an addition, that means they're doing what with each other? Multiplied. And dividing, we are, I put it back. You're subtracting where you're dividing, and a number in front means it's the what? So this is 3 to the third power, right? So this is going to be natural log of what?
4
times
3 to the third
divided by what?
12.
12. So we can simplify some more. So the natural log, what's 3 to the third power? And what's 4 times 27?
4 times, it'd be like 104, 6.
100 and something. 4 times 27. 108. And then what's 108 divided by 12? So the natural log of 9 is that simplified log. So expanding, we're stretching it out with pluses and minuses. Condensing, we're taking the pluses and minuses and making it as small as possible. All right, the last thing we're going to do is change of base formula, and it is very, very, very simple. Like probably the simplest thing we're going to do today. Yay!
Yay!
So excited to do something simple.
Simple.
Change of base formula. So we decided that my calculators are old-timey last week, right? And you just can't type in log base 6 of 72, right?
Yes, ma'am.
My calculators are old school. They won't do it. The new calculators will. So if you have an 84 instead of an 83, mine are all 83. So if you have a TI 84, it will do it. The TI 83s won't. But never fear because we can still do it. Okay? So say we have log C of A. These are just variables. So what you do is you take the big number. Now the bases go on the bottom, right? Y'all say that. Base goes on the bottom. So you're going to say log of A. Now if it doesn't have a base over here with log, what is my base? 10. So that's what the calculator will do, isn't it? Okay, and then divide it by log of the base. Or you can do the natural log of A divided by the natural log of the base. So you do the logarithm of the top number divided by logarithm of the bottom. Or you could do natural log, just whatever your calculator decides to hit. So we'll do one of each. What's our last example number we did? 10? So like say we want to find log base 3 of 8. So like I said, my old-timey TI-83 calculators, which is the same calculator I used in high school, is too old-timey to do this by itself, just typing it in. So we can do change of base. The base goes on the what? Base goes on the bottom. So we're going to take log of 8 and divide it by log of 3. That means everything is base 10. So our calculator will do that. So you just get out your calculator and turn it on. Where is the log button at, y'all?
Beside the 7.
Right there beside the 7. So all you have to do is hit log 8. Close your parentheses. Divided by log 3. Close your parentheses. Hit enter.
1.449.
Well, give me about 3 decimal places. 3. So that's what you just do. So you do the log of this number divided by log of this number. You can also do natural log and it'll do the same thing. So this next one I'm going to do natural log. So log base 6 of 24. And I want to do natural log. So natural log of what goes on top. 24. Base goes on the bottom. And you can type that straight in your calculator. ln of 24, close parentheses, divided by the natural log of 6, close parentheses, hit enter. We're getting about 1.774, right? Now, if I did log base 10 instead of natural log, I still would get the same decimal because the ratio corresponds. Oops. I'm going to give y'all one. I want you to try it on your own. I don't care if you use log base 10 or if you do natural log. I'll try that one.
Yeah, this is easy. Down.
I know. Do it. Write it down. Give me 3 decimal places, please. That's why you got most of this on your homework. Easy stuff.
Yeah, I know you care about it.
I sure do.
A teacher that won't care about it, that won't get nobody.
Hey, this is just what the state says to teach, and I'm teaching it. But this chapter is a lot of calculator punching, is it not? So what do you divide on this one?
The 8 and the 5.
So you do log or natural log. It doesn't matter. Just make sure you keep consistent. Whatever you do on numerator, you got to do on denominator. So 8 divided by, can't type an 8. I typed a 9, didn't I? Divided by log base 10 of 5. Did y'all type y'all's in like this? What'd y'all get?
1.292.
1.292. Did everybody get that? Yes or no?
Yes.
Okay. Y'all do one more for me. Log base 26 of 9. Which one goes on the bottom? This goes on the bottom. Even if it's bigger or smaller. Shh. I'm not done. What'd y'all get?
1.674.
Yep. Did you do 9 divided by 26? Nope. It's always base goes on the bottom. 0.674. Base goes on the bottom. No matter which one's bigger or smaller, base goes on the bottom. So that's change of base formula. Is everybody okay with change of base formula? Really simple. Put it in the calculator. Base goes on the bottom. Okay? That is the end of section 7.5. Test is on Wednesday. Have a good day.